we're going to go to number 18, and we're going to notice that the very first step they gave us matches how they started the proof. It's called the given. So you are allowed to write given for the first step, but you'll never write prove for the last step. That's not a reason. It's just we have to start with something, so you're given the first step. Okay, now this one is a little different because they gave you the statements and not the reasons. So here's how you're going to approach this one. You're going to say, what did they do to get from step 1 to step 2? How has it been changed, and what's the reason why they're allowed to do it? So if you notice, the angles were congruent, and then all of a sudden they said that their measures were equal. This might ring a bell to you. We've used it before with segments, and in the if-thens, this is this definition of congruence. So before you write it, let's look. See how it says if angles are congruent, if angles are equal, they're congruent. If they're congruent, they're equal. That's what they're doing there. They're just saying, hey, I realize if they're the same size and shape, their measures will be equal. So this is called the definition of congruence. Okay, step 3. Does it look like it came from step 2? Not at all. I mean, it doesn't even look anything like step 2. So what I'm going to do is go to my algebra steps. And you haven't seen this before, but there is an algebra step or an algebra property that is called reflexive. So I'm going to circle reflexive part, the reflexive property where it says A equals A. And you're going to think this is crazy because we use it in proofs, but when you say something equals itself, it's like a reflection of itself, and so it's called the reflexive property. So I'll show you why we're doing that in a second. Let's just fill it in first. This is called the reflexive property. It's like reflecting something. Now, the reason why they do this is because they want you to know that these two are equal, and we're going to take this dude and add it to that side, and then we're going to take this dude and add it to that side, and we're adding something equal to both sides of an equation. So think of it like we added the measure of angle 2 over here, and we added the measure of angle 2 over here. And now look at step 4. That's the result that we get by adding the 1 plus the 2 and the 3 plus the 2. So what that's called is the addition property. If we have something equal, we're allowed to add it to both sides of an equation. So you did this in Algebra 1. It just looks weird because it's with angles. So you added 2 to 1 and you added 2 to 3. So that's called the addition property. By the way, if you're thinking it's the opposite of what we did in the other proof where we subtracted them off, that's correct. Now we're adding them on instead of taking them off. Okay, step 5. Does that look anything like step 4? Not at all. It doesn't even look close to it. So now what we're going to do is go to our picture and see if we can find some way that allows us to know why this would be true. They had to have some reason for it. So let's go up to the picture and look at angle 1 plus angle 2 equals angle DEG. So the little angle plus the little angle equals the big angle. Oh, and then they did it again. Angle 2 plus angle 3 equals angle HEF. So now you go to your cheat sheet and you might be thinking, this seems a lot like segment addition, only it's with angles. And you would be right. This is angle addition. So let's go ahead and box this off. Angle addition is used when you add the two little angles up to equal the big angle. It's the same thing we were doing with the candy bar, but you're just doing it with angles. We said maybe you did it with pizza, like add a little piece of pizza with another little piece of pizza, you get the big piece of pizza. Okay, so this is called angle addition. Now, some of you might be wondering too, can they do two of them at once? And they are doing two of them at once. Because they're the same thing in the same step, you're allowed to do two of them at the same time. Okay, step 6. This is the big, huge, hard part of this proof. So some of you might guess what it is because you're going to start guessing, oh, when it's hard, it probably has to be this. But let me show you where this comes from. So will you guys go up and look at steps 4 and 5? It's usually like 2 steps above. Okay, so let's look at what might match. So do you guys see this 1 plus 2 and do you see this 1 plus 2? Those match, right? And then do you see this 3 plus 2 and this 3 plus 2, even though it's in a different order, it's still 3 plus 2? Those match. So watch what I'm going to do. In place of this 1 plus 2, I'm going to put the measure of angle DEG. That is going to go up in place of that blue statement. And in place of the 3 and the 2, I'm going to mark out the 3 and the 2, and I'm going to put this HEF up in place of that because I know that HEF equals 2 plus 3. So that's going to go up there. So that's how they got the measure of angle DEG equals the measure of angle HEF. And what do we call that when we take something out and replace it with something that it's equal to? And are you thinking substitution? Substitution is correct. Substitution. Now, some kids guess substitution and they just guess it for every step. Make sure you can actually, that's the fun part of it, well, you might not think it's fun, but that's the cool part of a proof when you can actually see where they put the things in place. Okay, from equals back to congruent, we know that by now. I'll show it to you. It's right here. It's the definition of congruence when you're allowed to change backwards from equals to congruent. So definition of congruence. Okay, we have one more. So we're going to do number 19. 19 is almost all blank, which is pretty scary. You will not have to do this on a test by yourself. I'm just showing you how it would be if you were filling in almost a whole proof by yourself. Okay, so what we're going to do first is we are going to go ahead and fill out step 1, which is the given. I'm just going to see if I can find my answer key. Make sure I'm telling you the right thing. But, oh, it's under here. Okay, so we're going to fill out given. And then step 2 says that angle ABD is a right angle. So what we have to do is we have to go up to the given and ask ourselves, what is it in the given that's making a right angle? So do you think that the perpendicular lines make the right angle, or do you think the fact that two angles add up to 90 makes a right angle? So you might think it's this one, but go to the picture and they're saying that angle ABD, this entire angle is a right angle. And we want to use the fact that the lines were perpendicular, or the rays. The rays being perpendicular makes a right angle. So why is it that perpendicular lines make a right angle? So go to your cheat sheet and look for something that says why perpendicular lines make a right angle. And not 90, but a right angle. And that is going to be your definition of perpendicular. Definition of perpendicular. And I'll go ahead and put lines behind it. Even though they're rays, it's still, that's a piece of a line. Okay, the next statement is blank. So we have to come up with something on our own. So what I'm going to do is I'm going to use this second part right here, this complementary idea, and I'm going to have you come up with what you could say about these angles. If 2 and 3 are complementary, they obviously want us to use that. So what could you say about complementary angles? So some of you are filling this out already. You're going to go to your cheat sheet if you need to, and oh yeah, 2 angles that add up to 90. Okay, well I got to use the angles in my proof, so I'm going to say the measure of angle 2 plus the measure of angle 3 equals 90. Step 4 wants us to use angle addition postulate. If you need to look it up, it's number 12. It's where we add the 2 little angles to equal the big. Now I want to point out these are all names of angles. Do you see any like numbers there? No. Angle addition will never have numbers. So we cannot have numbers here. We have to have, I mean, we can have numbers of angles, just not degrees. Okay, which angles do you think we could add up to equal the big angle? And the answer is these 2 little ones. So I can use the numbers, but the big one needs to be a name. I can't say 90. So I'm going to say the measure of angle 1 plus the measure of angle 2 equals, I cannot say 90 because that's a degree. I've got to say the measure of angle ABD. All of these 3 have to be names. Names and not degrees. Okay? All right, the rest of this is blank. Pretty scary. But I'm going to lead you through this to see if you can get it. So what I would like you to do next is, for step 5, I would like you to look at what we have so far that we might be able to take out and put in its place. Okay, so if I look, I know that I have, oh, I got to do one other thing, I'm sorry. Step 5, I haven't used this yet because I was going to try to replace it, but I don't have enough. We got to use step 2 to change to step 5. So ask yourself, if you have a right angle, what could you say about the right angle? And we know that a right angle, the measure of angle ABD would equal 90. How would you know to do that? You wouldn't. That's why I'm leading you through this. You would never probably, the only thing I could say is you would know that you haven't used it yet. And that's definition of a right angle. Oops, I forgot to fill in step 3. Step 3 was using the complementary, so this was definition of complementary angles. Okay, now, this is what I want to see if you guys can do. So I'm going to highlight steps 4 and 5. So let's look at 4 and let's look at 5. And I want you to look for something that matches, that you might be able to take out and replace. So when you look, some of you are thinking, oh, cool, I see an ABD in both, right? So go ahead and scratch out the ABDs lightly so I can still read them. But get rid of them, and then we're going to input that 90 in place of ABD. We're allowed to do that because they match. So we're going to get the measure of angle 1 plus the measure of angle 2 equals 90. And that is called substitution property. Okay, next, what I'd like you to do is, and I'm leading you through this, you would never be able to write this on your own yet, I'm just showing you. I would like you to use steps 3 and 6. And I need you to see what you could do with 3 and 6. Do you see things that match? So some of you might notice that the 2's match, but the entire side doesn't match. Like this entire side doesn't match this entire side. So do you guys notice the 90s? Okay, so let's take the 90s out, scratch them out, and let's take all of this and put it in place of that 90. So all of this is going to go up in place of 90. So I'm going to get a very long equation. I'm going to get the measure of angle 2 plus the measure of angle 3 equals the measure of angle 1 plus the measure of angle 2. That is called substitution property again. So kids ask me, can you have 2 substitutions? Yeah, you could have 30 if you wanted to. They just substituted twice. Okay, next, when you look at this equation, you might notice that there's a 2 on each side. So we're going to subtract off the 2's. It's like an equation where we minus them off. So this is going to be left with the measure of angle 3 equals the measure of angle 1. That is called subtraction. Keep in mind, we did not replace it. We just took it away. So subtraction is when you take away, you don't replace. And then I know the order's flipped, so technically we should probably flip this around using something called symmetric. But I'm just going to change it from equals to congruent by using the definition of congruence. I do want to point out, though, on your cheat sheet, if you ever flip something around, that's going to be symmetric. I just didn't have enough steps to do it, but technically I should flip it around by symmetric.